Hello. Thank you very much for joining. I also do thank the organizers of Social Ontology for making this possible. I'm Majid D. Beni. I'm an assistant professor at ODTÜ Ankara, and I'm going to speak about aspects of my theory, philosophy of science, cognitive structural realism, and its possible overlap with theories of social ontology. So the outline of the work is quite straightforward. I'm going to speak about cognitive structural realism. It is a theory of philosophy of science that I have been constructed a while ago. Then I'm going to speak about a criticism that has been posed by Max Jones, to whom I owe gratitude. In a nutshell, the criticism indicates that cognitive structural realism is dismissive of the social aspects of scientific practice. Then I show how the criticism could be addressed. And then I end this talk by posing a question. The answer that I get to this question in the Q&A and the comments may help me to enhance the plausibility of cognitive structural realism. So in the beginning, there have been scientific realism and scientific anti-realism, and scientific realism has been liable to two important criticism: metaphysical underdetermination and pessimistic meta-induction. I'm not going to, this talk doesn't cover scientific realism and the criticism. Sufficient to say that structural realism is a modest form of scientific realism that provides answer to these criticisms, that addresses these two criticisms and is not liable to them. And it is modest in the sense that it says that epistemic and ontic commitments have to be made on the basis of the form or a structure of the theory, rather than its content. And some versions of ontic structural realism are committed to naturalism. Russell, Eddington, and Poincaré are among the predecessors, and John Worrell, Stephen French, and James Ladyman are amongst the active proponents. However, I'm going to criticize structural realism, and cognitive structural realism is actually a form of structural realism, but it takes the rule of cognitive agent into consideration. The orthodox form of structural realism indicates that the structure of scientific theories represent the causal structure of the world, and the structure of the theories is regimented in terms of set theory and model theory. Then, a structural realism models the relationship between scientific structures and their targets in the world, meaning the causal structure of the world in terms of isomorphism. An objection to orthodox versions of structural realism that has been expressed by me on several occasions is that the formal tools that structural realism uses are too abstract to ground a down-to-earth account of scientific representation. That is to say that the formalism is too abstract to underlie a realistic account of scientific representation. And the formal account of scientific representation is rather dismissive of the rule of the human agent. It is against this background that cognitive structural realism is presented to indicate that it is possible to base the account of scientific representation on a scientifically defendable account of dynamical relationship between the agent and its environment. And it has been stated in a 2019 book in Springer, Cognitive Structural Realism, which provides a radically naturalistic solution to the problem of scientific representation. The main contribution of the book is that it replaces set theory or model theory as the venue of representation by embodied informational patterns that are described by computational neuroscience. According to this theory, the relationship between theories, scientific theories, and the world supervenes on the relationship between the organisms and the environment. So scientific representation supervenes on the relationship between the brain of the organism, which is in this case a scientist, and its environment. And as such, the theory pays due attention to the role of agents or human beings, even though it is a theory of structural realism, like even though it is a form of structural realism. So uh, in order to provide a scientific basis for the account of relationship between the brains and the world, cognitive structural realism draws on theories of predictive coding and free energy principle. Uh, so free energy principle indicates that in order to maximize their survival, the organism must minimize their surprisal or free energy. The theory has been stated by Carl Friston and colleagues, and it holds that the organisms tend to remain in non-equilibrium steady states by avoiding to get into unpredicted situations. That is to say, by remaining in a limited number of states. And free energy is defined in terms of being equal or larger than the surprisal. And the generative models provide mapping relationship from outcomes to hidden states. In this theory, generative models are probabilistic models of dependencies between causes and consequences, which are characterized in terms of likelihood and prior densities. So I do not delve into details. The thing is that cognitive structural realism's account of scientific representation is based on a scientific theory that describes the relationship between organisms and the world in terms of predictive processing and free energy minimization. But the objection that has been voiced by Max Jones indicates that even though the theory is right to assume that scientific theories are byproducts of the brains of human beings, this is not sufficient to identify the theories with the representations in people's brain. Brains do not create a store or test theory. Scientific communities do. Scientific theories are arguably social phenomena, and no single scientist can keep the entirety of a theory in her head, according to Jones. So this is the scheme of the argument. Cognitive structural realism relies on free energy principle to account for scientific representation. But free energy principle is a theory of individual brains. From these, it follows that cognitive structural realism supports an individualistic conception of scientific practice that is separated from social reality. But science is a social enterprise, and if that's true, cognitive structural realist account of scientific representation is wanting, given that it focuses too narrowly on the role of the brain of individual organisms at the expense of the wider picture, which includes the social aspects of scientific practice. So in order to make cognitive structural realism invulnerable to this criticism, I'm going to assume that scientific communities are distributed cognitive systems and science is byproduct of the activity of these distributed cognitive systems. There are nice precedents for this in works of Kirsch and Hutchins and Ronald Geary, who draws on works of Hutchins to show that scientific activity is taking place inside a distributed cognitive system. However, in order to answer to the criticism, in order to address the criticism, we have to be able to show that free energy principle is not a mere theory of individual brains or a theory of mere individual brains. This means that we have to go beyond classical works on distributed cognition and develop an account of distributed cognition from within the free energy principle framework. This is because cognitive structural realism depends on free energy principle. And it is possible to develop an account of social communication from within free energy principle frameworks. I'm referring to works of Friston and Fries, among some other significant works in this field, to show that we can account for the relationship between two agents who are chained together in a mutual dynamical adaptation relationship that subscribe to the same generative model. This subscription enables this agent to predict each other's actions and minimize their mutual prediction error. So basically, we can account for social communication on the basis of minimization of free energy. When exemplified in terms of performing a duet or a song, this could mean that the participants, which are two birds in this case, the case that has been discussed by Friston and Fries, are singing from the same hymn sheet. In the same way, we could assume that when brains engage in a collective activity, such as singing together, playing a symphony, or discussing a scientific idea, they will be able to understand each other and communicate meaningfully based on their capacity to predict each other by using a shared generative model. And this provides a basis for revising cognitive structural realism, assuming that the formation of precise scientific representation is the result of the scientific group's endeavor to minimize its entropy by reducing the discrepancy between its models and the environment. So scientific activity takes place in a complex hierarchical organization that carries out the distributed minimization of variational free energy across various scales. In such organizations, generative models at the scale of scientific groups enslave the state of generative models at the level of individual scientists, which in turn enslave the generative models at the subpersonal level. So it is generative models all the way down to the level of neuronal population and all the way up to the level of scientific group, which all are in the business of minimizing free energy of the system. According to this picture, the shared generative model of scientific group is a shared repertoire of scientific activity. So in the same way that the original version of cognitive structural realism was using generative models to account for scientific representations, the revised version draws on shared generative models to account for shared scientific activity. The scientific group relies on the information that is produced by individual scientists at the lower scales to make progress, and at the same time, individual scientists' collaboration is coordinated based on the shared generative model that is formed at the scale above. This conception of scientific activity ensures that scientific organization as a whole, consisting of various scales which include individual scientists and scientific groups, is involved in the minimization of variational free energy. So from what we have discussed thus far, we could conclude that cognitive structural realism provides a radically naturalistic account of scientific representation. And it is possible to flesh out theories of scientific communication under free energy principle. Therefore, it is not the case that cognitive structural realism supports an individualistic conception of scientific practice that is separated from the social reality, and as such, cognitive structural realism could take the social aspects of scientific activity into consideration. Cognitive structural realism is revised and made invulnerable to the said objection. However, it leads to the matter of ontology. What sort of ontology could consort with cognitive structural realism? So, to the first approximation, I would be willing to keep things as austere as possible. I'm going to assume that to be the entities or structures that are represented by scientific theories, plus the individual scientists that contribute to the formation of scientific representation. But as we have already seen, science is a collaborative activity, and scientific activity is not always decomposable to the activity of individual scientists. In the same way, we have discussed that the free energy principle is not necessarily a theory of individual brains. If that's true, it might be possible to assume that scientific corporates and groups whose activity is not decomposable to the activity of individual scientists are genuine ontological entities. So could we draw such a conclusion? It might be to take such a positive attitude toward the ontology of social groups by assuming that science is a collaborative activity and the activity of scientific groups could not be decomposed to the activity of individual beings. If that's true, it follows that scientific corporates and groups whose activity is not decomposable to the activity of individual scientists are genuine ontological entities. It might be to draw this conclusion, but I have some hesitations. I do not want to jump to the conclusions. So my hesitations come from the fact that I have some reservation about the possibility of reading of the ontology directly from the account of dynamical emergence of knowledge. It could indeed be the case that the emergence of knowledge is a result of causal dynamical relation between scientists. And scientific knowledge may not be decomposable to the pieces of knowledge in the brain of individual scientists. However, from this, it does not follow that scientists do constitute groups that are authentic and genuine ontic units. That is to say that dynamical composite systems that generate knowledge do not need to be composite ontic entities, even though it is the case that scientific knowledge is not decomposable to the knowledge of individual scientists. So my reservation simply is that from the fact that scientific knowledge couldn't be decomposed to the knowledge of individual scientists, it doesn't follow that scientific groups are authentic ontic posits in the same way that individual scientists are. There might indeed be grounds for establishing the ontic authenticity of social groups, and I have explored these grounds in another work where I assume that embodied informational structures are extended into the webs of social relations. But I'm not sure that the grounds that we discussed in this talk, the fact that scientific knowledge couldn't be decomposed into pieces of knowledge in the brain of individual scientists, is enough for taking a positive attitude toward the ontology of social groups. So I'm going to end this talk with a question. Even if we assume that there are independent grounds for establishing the reality of social groups, scientific groups, as authentic ontological entities, would this commitment to the ontic status of scientific groups enhances the plausibility of cognitive structural realism. In other words, in order to defend the plausibility of cognitive structural realism, do we need to also make commitments to the authenticity of scientific groups as genuine ontic entities, as genuine ontic posits? So I think that this is a good place for ending this talk. And I thank you very much for your attention.